Hello, welcome back. So in this lecture, we will start a discussion about chapter 7 regarding exceptions. So this is chapter 7, exception. So in this chapter, we will discuss uh, what is exception and how do we handle exception, okay, with try, catch, and finally block. And also we will discuss Java exception class hierarchy, okay? And we will also discuss the difference between checked and unchecked exceptions. Okay, so the first part is about what is an exception, okay? And so it is defined as some runtime issue. So here, be careful, it's a runtime issue, okay? That will disrupt the normal flow of the program's execution, okay? And of course, yeah, you may say, yeah, so far we have learned is that whenever we write a program, we need to take into account various scenarios and conditions that to prevent some bad thing happens during runtime. So you can do condition check to prevent exception. So of course, that's one option, okay? But for some very complex program, okay, then it may have many potential error conditions. And sometimes when we try to figure out various scenarios for error conditions, we may not be able to take into account every scenario, etc. So individual checking for each condition, then it's probably impractical. Is it? So in this scenario, how do we still prevent this kind of runtime issue? The runtime issue is only when the program executes, some unexpected thing could happen, is it, to disrupt the normal flow. So one of the best option, so the best option to do it is to handle abnormal conditions using exception handling. So exception handling, yeah, it will provide enough uh, uh, safety, kind of like enough safety check and prevention. Okay, so this is a general concept about exception. Okay, so we just discussed, so exception is the best way to prevent the unexpected runtime uh, disruption for the program. So how do we handle it? One way is we use the try-catch block. Okay, so we can surround the code which might cause issues with the try-catch block. So the syntax, it looks like this. So you have this try keyword, and you have the pair of curly brackets, and all of the code that might cause issue, okay, and we call it can throw exception. You put all the code here, okay? And then we have this catch. So this is a keyword and some type of exception as a parameter, okay? And then you have another curly brackets and So at this scenario, okay, what we will do to handle the exception. And exception, then the code can cause exception. It may be able to cause different exceptions. So we can use multiple catch to catch each individual exceptions. Okay. So for different scenario of exception, then you handle it differently with a different catch block. Okay. And at last, you can have this finally block. So code will always be executed at the finally block. So this is the general syntax for the try-catch block. Okay, and in Java, the exception also has its class hierarchy. Okay, but no matter what, so all exceptions, they are also object because object is a root class of all of the Java objects, okay, classes. And along the exception, for the exceptions, okay, there is a superclass called throwable. Because be careful, this is a class, not an interface, okay. And the parameter to the catch block, if you recall, the catch block has, it looks like a function, is it? The method, so it has the parameter, is it? So the parameter is a parameter of this block. They are all subtypes of this throwable superclass, okay? And the director subclass of throwable, there are two kinds. One is called exception, so has, and one is this arrow. So these two are two different, okay? And for the try-catch blocks and the finally, so try-catch and finally block, so can they handle both of these two types, exception and arrow? No, the answer is no, okay? So this try-catch and finally block only apply to exception. It doesn't apply to arrow, okay? So arrow, you cannot catch it basically. So there is no way for our program to prevent arrow happens. It's out of our control, okay, programmer's control. But exception is under our control, okay? We can use try-catch block to control it, okay? To handle exception and recover it for exception. But arrow, it's created, it's external, it's not the program itself, okay? So it's external to the Java application. So we cannot, so you cannot catch arrow using try-catch block and handle it. And also program cannot recover after error happens. Okay. So one example is like a Stack Overflow. Okay, because this is out of the program's control. Okay, or like memory run out of memory. That's out of program's control. So that's why try-catch block will not work with it. And also program cannot recover from it. Okay, so in this diagram, it shows the exception class hierarchy, okay? So here we have the superclass throwable. Under it has arrow and exception, okay? And we just discussed arrow cannot be handled by the try-catch block. So also cannot recover. And here to also list some error like virtual machine related error, is it a Stack Overflow error, out of memory error, okay? While exception, this can be handled. with the try-catch block. And also it can recover. Okay. And there are also different kinds, subtypes. One is the runtime exception, okay, like arithmetic, like a class cast, index out of bound, input mismatch, null pointer. Okay, let's take. So this is the runtime exception. There's another type called I/O exception. Okay, like file cannot be found exception. Okay, socket with related with internet or networking. Okay, so and then also for different type handles differently. So we will discuss that. Okay, let's temporarily stop the concept and let's take a look at the code, okay, to have better understanding about exception. Okay, and this is our first example in this chapter. It's Java exception. Example one, exception. Okay, it's here. This example, okay. So now in this chapter, okay, it's a pretty simple one. So let's take a look, okay. And here we will get input from keyboard, okay. So using standard input, okay, system in. And we use the scanner to handle it. So pretty simple, just do some division, okay? And so we have A, an integer number, and B, an integer number. Then you can do A divide by B, is it? And we can easily find that over here there is an issue for this segment of code because B could be 0, is it? So if we don't do any condition check, if you just write this program, that will cause the when you run the program, if you enter B at 0, the program will crash. Okay, so it will not run correctly. Okay, then you may say, okay, then why don't we add some condition? That yeah, we could add some condition check. Yeah, so to fix that runtime error, yeah, you can do this, okay. For the input bit shouldn't be 0. If it doesn't, it's not 0, then you do the division. Otherwise, you won't let it do the division. Is it okay? Of course, this will work. But as we explained before, in a complex program situation, then we may not be able to um, uh, list all of the condition, this kind of condition that can cause error, runtime error. So sometimes we may not be able to. So in that scenario, then the best way to do it is to use try, catch, finally block. Okay, so let's see what is that. How do we write it in a program? Okay, use a try-catch block. So we, instead of doing that as using the condition if else, okay, we are going to write it with the try-catch block. And here we have a function, result of function. We are going to do the division inside the function, and the input of this function is that scanner object. Okay, so let's take a look at this function. So for this function, then if you take a look, this part of the code is what we just did, is it collect inputs, and do division. Do division, and then we collect the input with scanner. Okay, we get input, and then we do division. But this time we put it in the try block. Okay. And then we have the catch. So in case if B is 0, that if try to do it will have disruption. So basically arrow will throw. So exception will be throw. Exception will be thrown here. Thrown here. Is it? So okay, then you can have this catch. Catch that. So that divide by 0 is called arithmetic exception. So you can, okay, try to catch that exception, arithmetic exception. Then you just, so over here, we just handle it very simple. We just output, okay, divisor cannot be 0, okay. There may be some other except scenario that for the input, they both should be integer here in our case. But maybe you enter string that or character. Then that exception is called input mismatch exception. So you see, we can also catch that exception. Then it prompts the user that something entered is not correct. Okay. And here, this exception, this is a very general, is that if you recall, the throwable is a super type. Under it, we have exception and arrow. And arrow cannot be handled with try-catch block, but all kinds of exception are subtypes of it. Is it? So if you use this exception, it can catch all sorts of exception. Okay, so if there are some other type exception that we haven't predicted, then those exception will be caught here, and it will let us, okay, anyway, some error will happen. That okay, so all the exception are caught, and then this is finally blocked. So this so of the codes that after the exception handling, then can go here, go the finally. Okay, so this is the idea about the try, catch, and finally block. Okay, and also be careful. Okay, here don't put this catch exception ahead of arithmetic and input mismatch. Because if you put this exception ahead of the other two for the catch, then the other two never be um, caught, is it? Because this exception covers the arithmetic and input mismatch. Okay, so that's why here we put it last. Okay. Okay, so that's about this example, and we can take a quick look to see how it runs. Okay. Okay, now here is nothing. Okay, so we can run the program. See, okay, so suppose here, okay, A is 10 and B, that's input 0. You see it catch that it also tells you divisor cannot be 0, etc. So that oh, you see the program seems still runs smoothly, as that user won't be surprised by the crash of the program. And we can also run like, okay, A is 10 and B is, we try to enter some characters. So that's where I said, okay, input mismatch. So your input must be an integer, okay? So that's this two scenario, and we can also do some other thing. Okay, let's see. Suppose here we in so instead of using the scanner, is it the function parameter is a null, so that should cause some issue, I guess. But let's take a look. So then you see, so the program will not work. Is it because it go to that exception? Is it the very general scenario? Okay. Yeah, so that's about the basics of exception. Let's stop here for this lecture. We will come back to discuss more cases about exception. See you.